In this chapter, we will discuss about generator ventilation. Generator room ventilation is crucial to ensure the safety, efficiency, and longevity of the generator. Proper ventilation helps in maintaining an optimal operating environment by preventing overheating and removing harmful gases like carbon monoxide and nitrogen oxides that can accumulate during generator operation. Here are key considerations for generator room ventilation. Number one, airflow and temperature control, inlet and exhaust vents. Ensure that there is adequate air supply for combustion and cooling. Typically, intake vents bring in fresh air, while exhaust vents remove hot air. The inlet should allow enough air for both generator cooling system and combustion process. Ambient temperature control. Maintain the room temperature within the recommended range for the generator. Excessive heat can reduce generator efficiency and lifespan. Install fans or HV system if necessary to control the temperature. Proper clearance. There should be enough space around the generator for air to circulate freely and avoid hot spots. Manufacturer usually specify the minimum clearance needed for optimal airflow. Number 2. Exhaust system exhaust gas removal. Generators produce harmful exhaust gases such as carbon monoxide. Ensure the room has an exhaust system such as duct or pipes to safely channel these gases outside. Compliance with regulations. Check local regulation and standard regarding exhaust ventilation to ensure the system meets safety guidelines. Backdraft damper install to prevent backflow of exhaust gas into the room. Number 3. Ventilation rate. Air change per hour. Calculate the appropriate air change rate based on the size of the generator and the room. This will ensure that heat and gases are removed efficiently. The fan sizing is to ensure that fans or ventilation system are appropriately sized to handle the heat load of the generator. Underpowered fans can result in insufficient ventilation. Number 4. Sound attenuation noise control. Generator rooms can be noisy and ventilation openings may allow noise to escape. Use sound attenuation materials around vents and ducts to minimize noise levels in surrounding areas. Redundancy and monitoring backup ventilation. In case of primary ventilation system failure, consider having a backup system in place. Monitoring installed temperature and air quality sensors to monitor generator room environmental in real time. These sensors can trigger alarms if unsafe conditions arise. Number 6. Maintenance regular inspection. Ensure that ventilation systems are regularly inspected and maintained to avoid blockages and wear that could reduce their effectiveness. Filter replacement. If filters are used in the ventilation system, they should be cleaned or replaced as part of routine maintenance. Proper ventilation is vital for generator performance and safety. So ensure your system is designed and installed accordingly to best practice. And basically the airflow design and requirements. Efficient airflow is essential for generator ventilation to prevent overheating, ensure proper combustion, and maintain the generator performance over time. A detailed airflow plan should be developed based on generator size, room layout, and operational needs. Inlet ventilation. Air for combustion. Generator need constant supply of oxygen to burn fuel inefficiently. Ensure the room has adequate inlet ventilation to meet the air combustion requirements of the generator combustion process. In cooling air, in addition to combustion air, generator require cool air to maintain optimal operating temperature. Calculate the volume of cooling air based on the generator heat rejection data, usually provided by the manufacturer. A rule of thumb is that the inlet should provide a flow rate of around 2.5 to 3.5 cubic meter per kilowatt of generator power output per minute. Vent placement. Inlet vent should be positioned at a lower level. As cooler air tends to stay lower, proper placement ensures that the fresh, cool air flows towards generator. Exhaust ventilation, heat dissipation. As the generator operates, it generates a significant amount of heat that must be expelled. Exhaust fans or vent should be installed to discharge hot air outside the room. Exhaust vent should be placed at a higher level to remove hot air that arises. Airflow rate ensures that the exhaust system can handle the airflow requirements. The generator's heat rejection rate, room size, and the temperature rise allowed within the room determine the rate at which air to be exhausted. This is often calculated as air change per hour. Air velocity. Avoid air velocity that are too low as they may lead to air recirculation, or too high, which could cause noise and energy inefficiency. Typically, inlet air velocity should be around 5 to 7 meter per second. Next, exhaust gas ventilation system. The removal of harmful exhaust gases produced during combustion is critical for generator room safety. These gases include carbon monoxide, nitrogen oxides, and sulfur dioxide, which can be toxic and corrosive. The exhaust piping, proper routing, exhaust gas should be directed towards outside the building through an exhaust pipe or ducting system that complies with the local building codes. The exhaust pipe should be made from materials resistant to high temperature and corrosion, such as stainless steel material or coated carbon steel. Back pressure consideration. Ensure that the exhaust system is designed to minimize back pressure. Excessive back pressure can reduce the generator efficiency and lead to overheating. Use smooth, properly sized pipes and avoid sharp bends to reduce resistance to airflow. Exhaust stack placement. The exhaust stack should be located away from air intakes, doors or windows to prevent re-entry of exhaust gas into building. Should be high enough to ensure that the gas is dispersed safely into the atmosphere, and follow local regulations for minimum height requirements. Muffler and sound attenuation. The exhaust system often include mufflers to reduce noise from engine exhaust. Proper selection and installation of muffler help attenuate noise without restricting airflow or creating back pressure. The cooling system integration. Radiator cooled generators. Some generators come with integrated radiator that cool the engine. In such cases, ensure that the room ventilation system is designed to handle the heat rejected by the radiator. This often requires dedicated ductwork to expel the hot air emitted from the radiator directly to the outside. The room must have a sufficient airflow to prevent heat from accumulating around the radiator and engine, which could lead to overheating. Remote cooling system. In larger installation, remote cooling system are used to cool the generator. The system are often placed outside the generator room. The ventilation system for such steps should be designed to remove residual heat generated by the engine and exhaust components. The next one will be the safety consideration, gas detection and ventilation failure alarms. Install gas detectors to monitor the level of harmful gases in the generator room. These detectors should be connected to an alarm system that alerts operation or operators if dangerous gas concentration are detected. Include temperature and airflow sensors to detect any malfunction or reduction in ventilation performance. If the cooling or exhaust system fails, alarm should be immediately notify the maintenance team. The fire protection as a generator involve combustible fuels. Fire safety is critical. Proper ventilation can prevent the buildup of flammable vapors, but additional fire protection measures like fire rated ducts suppression system, and fire resistant doors are recommended. Ensure that the ventilation system does not compromise the integrity of any fire-rated walls or enclosure. Emergency ventilation system. Consider installing backup ventilation systems, especially in mission critical operations. This can include emergency fans or vents that active automatically in case of the primary system fails. The noise control and attenuation ventilation openings. Airflow through vents can source of noise. Install sound attenuators or louvers at air outlet and exhaust point to reduce noise transmission. While maintaining airflow, vibration isolation, ventilation system and fan should be mounted using vibration isolation device to prevent noise from traveling through the building structure. This also extends the lifespan of equipment by reducing mechanical stress. The ventilation rate calculation. To calculate the ventilation rate for the generator room, you need to know the generator heat rejection rate, the room permissible temperature, the specific heat capacity of air. The formula to calculate the required airflow is equal heat rejection multiplied by 1000 divided by air density multiplied by specific heat capacity multiplied by temperature rise. This ensures the ventilation system provides sufficient cooling capacity to maintain operating temperature. The maintenance of ventilation system. Regular maintenance is key to ensure the ventilation system functions correctly over the generator lifetime. Inspection schedule. Set up a schedule for regular inspection of air intakes, exhaust systems and ductworks. Look for blockages, debris buildup or corrosion. The filter replacement. If your system uses filter to prevent dust and debris from entering, replace them periodically to maintain airflow efficiency. The fan and motor maintenance. Lubricate fan motors and inspect moving parts for wear. Replace any worn out components to prevent system failures. The exhaust pipe cleaning. Periodically inspect and clean the exhaust pipe to prevent soot buildups, which can lead to reduced efficiency and potential safety hazards. Next, complaints and standards. Ensure that the design and installation of the ventilation system adhere to application standards and regulations such as NFPA 110, standard for emergency and standard power system as per ASHRAE 62.1. Ventilation for acceptable indoor quality. EPA and OSHA guidelines for emission control and workplace safety local guidelines vary by jurisdiction and should always be consulted for specific requirements. Proper room generator ventilation is a critical component of a safe and efficient power systems, and detailed planning should be done to accommodate all factors from air management to safety protocols. If you like this video, just click like and subscribe. For the detailed design training, you can contact +91 95970 56755. Thanks everyone.